Hi all, a very good morning. So in the part of our yesterday session, we started looking at the security white papers and where we learned about why is cloud like AWS being a trusted partner, right? So today, if we go down to any client and ask them that would you like to move your assets towards the cloud and put them across there? So they might have a lot of questions, right? How is the security all about? Whether we will be able to manage the data, right? So there will be a lot of questions. And what if someone comes into the data centers and steals out all the hard disks and other things happen, right? So there might be a lot of questions that people might get through. So in the part of the security white papers, we are specifically learning about how the Amazon has actually set up the data centers and what are the industry standards they basically follow, so that we will be able to convince the clients saying that yes, Amazon does follow this kind of specific security standards as well as the industry level standards, which can actually help in to ensure that whatever we are moving towards, whatever data we are moving towards the cloud is completely safe, right? So in that specific portion, we had discussed some things about. So we discussed about what is cloud computing, the advantages of cloud computing. Then we discussed about the way the security has been set up in the Amazon. And then we discussed about the compliance levels that Amazon follows up as per the industry standards. And then we discussed about the shared security model, where it's not just the responsibility of Amazon to secure the cloud infrastructure, but it is actually about the responsibility of the customer as well as the AWS together. So we call it as a shared security model, because the infrastructure what Amazon is going to put up, for that Amazon is responsible. But whatever data we are going to host on that AWS cloud, we are responsible for that, right? So both have to take the responsibilities considerably and then secure the data. And then we learned about how the storage decommissioning is done in the real time. So we usually know that any magnetic device or any electronic device has a specific age, right? So after which we may need to replace it with a new device. So whenever the specific device reaches out its useful life. So after that, what are we going to do with the hard disk? So they are going to physically destroy it and degauss it as per the industry standards, right? So as per the details which are listed in the DOD 5220.22-M and the NIST 888, which are the guidelines for the media sanitization, the magnetic devices all after their useful life are to be physically destroyed. And then we learned a little about the network security. So we have got protection while the data is being is in transit, that is using the SSL layers. And apart from that, we also have the NACL to protect ourselves from the network security. And then we learned about the corporate segregation. So what is Amazon.com and what is AWS.Amazon.com? So both are a company and one company entity, but they are completely logically they are completely separated using the set of complex network security and the segregation devices. And then we learned about a little more on the network monitoring and product protection, that is about DDoS, man in the middle attack, IP spoofing, port scanning. So these are the different kind of attacks we can usually expect that can actually happen on any of the data centers. So Amazon really does protect it from us. So it does protect from all of these ethical hacking attacks which can happen, like DDoS, man-in-the-middle attack, IP spoofing, port scanning, and the packet sniffing by other tenants. Now, in terms of the IP spoofing and the port scanning, Amazon would allow you to do the port scanning only in case if you have let them know about it in advance. So if you're not letting them know, then it is a violation against the AWS acceptable use policy. So we must always request a vulnerability scan in the advance itself. And then we learned what are the different types of credentials that we have in the AWS. So specifically, we have the console user ID and the password at the first level, and we can have MFA on top of it. And the other way of accessing the AWS console is using the access keys, that is access key and secret access key. And to log in inside the EC2 instances, we have the key pairs, and then finally we have X509 certificates. This is specifically used when we are trying to have signed URLs. Remember the concept of signed URLs that we discussed in the CloudFront distribution. So how do we generate that temporary token? That specifically happens with the help of this X509 certificates, which are digitally signed SOAP request to the AWS APIs. And in the part of today's section, let's continue to explore the part of the security processes. So we are going to discuss about something called as trusted advisor. So trusted advisor is actually a kind of service which is available in the AWS itself. So long ago, when Amazon first had set up its data centers, right? So when it started its AWS cloud, it didn't have this trusted advisor. It usually used to have a team of 5 or 10 members who were called as a trusted advisor team. They used to visit towards the client, and then they used to audit the each and every part of their AWS environment and help them understand what is going wrong or what is going to be correct. But eventually Amazon found out that they are having a lot of clients over the cloud, and it really becomes difficult for their team to be sent to each and every point in the world, right? So that is when they came up with a service called as trusted advisor, which actually inspects your AWS environment and makes the recommendations when the opportunities may exist to save the money. It also helps you to improve the system performance and also close the security gaps. Now let me show you how does it appear in one of my AWS console. Okay, so in this side of the services, I'll just go and try to find out trusted advisor. So you would be able to see this. So specifically, this actually gives me a good overview of all the things like cost optimization, performance, security, fault tolerance, and the service limits, right? So it gives me an idea whether I'm making good usage of the AWS in terms of the cost optimization, or can it be still further reduced. In terms of performance, whether I'm making good use of it, and in terms of security, is everything correct, like NACL rules or the security group rules, are everything correct, or is there any problem? So you can specifically see here there is one red mark. So let's go ahead and see what is it all about. So here in this case it says in the US East one there is with a security group with the name Windows SG, in which the port number 3389 is opened up for the entire world, right? So it is specifically asking me to saying that you should be always ensuring that it should the port number 22 and 3389, the place from where we will be able to log in into either a Windows box or a Unix box, shouldn't be opened completely to the entire world. It should be restricted to a set of IP address, or maybe to just my system IP address itself, right? So that is a red mark warning here, that is like action recommended to be taken up, because that can be a threat. And then the service limits, it's showing me what all services I'm basically using and whether I'm hitting up the limits or not. So currently everything is going fine. And the fault tolerance, basically it's showing if I am able to ensure that the services are working fine, even though like until now availability zones are not been down. So if something goes down automatically, this would recommend that is the fault tolerance happening up perfectly or not. So specifically, Trusted Advisor inspects your AWS environment. So it's going to completely make a scan of your AWS environment, and it's going to let you know what all services you have been using, whether is there a problem with any of the service that you have been using, and whether there may be an opportunity that exists to save money as well as close the security gaps. So it provides alerts on several most security misconfigurations that can occur, including the leaving certain ports open. So just now we saw one of our port 3389 in the US East one is open, because that makes you vulnerable to the hacking and unauthorized access. Neglecting to create IAM accounts for your internal users, allowing you to allowing public access to Amazon S3 buckets, not turning on user activity logging, and not using MFA on root AWS account. So it does keep a check on all of these things. So if you have any of these buckets which is publicly accessible, it would show that this is a kind of bucket which is publicly accessible. Maybe you would like to make it as just a private one with certain amount of users to be shared with, right? Sometimes we may not have enabled the cloud trail activity for the services that we are using. So let's say we are using lots of services across the AWS, so we may not be using the logging across all of them. So it does ask us to ensure that we also open up the cloud trail for a certain set of services, so we will be able to manage it much better in terms of logs. So if something wrong happens, we will be able to easily look through the logs, from which IP address what request came and what happens through. Now, how does the instance isolation happens? Instance isolation is basically like, now whenever we see any of the AWS data center or any cloud data center, let's say, so how is the system being set up? There are lots of servers in each of the rack. So I'm sure you guys would have seen one small image before in our session here. Right, so usually the data centers would be something like this. So there will be a lot of racks, and inside these racks is where we are going to spin up our servers, right? So these are all actually connected with the wires and the devices. Yeah, physically it would be something like this. So there will be a lot of this is a rack inside which we are going to place all the servers, and these are all connected with the help of wiring. And inside this we are going to actually launch our servers. So if I'm going to launch a Windows server, it will be in the same, as well as if I'm going to launch one more Linux server or one more Windows servers. Usually this has a specific capacity of launching at least minimum of 50 or 100 EC2 instances, and we'll be able to launch inside one of the machine itself. So how does that basically happen, and how can we ensure that each EC2 instance which is launched in the same server box or the same hardware box are isolated from each other? Which means even if I have logged into one of them, will I be able to log in into one of my nearby instances? It is like I have two houses on the same floor, will I be able to get inside the other one, right? So no, we cannot get inside through, because there is isolation that has been done. So how is that isolation being done? Using the hypervisor. So the different instances running on the same physical machines are isolated from each other by a Zen hypervisor. Remember, Amazon has implemented the Zen hypervisor in the real time to isolate the EC2 instances. In addition to the AWS firewall resides within the hypervisor layer. So let me show the diagram how it is going to be. This is like this. So this is the physical interface on which we are going to actually have lots of EC2 instances. Okay, so I have a hypervisor here which is actually going to take care about it. So whenever a customer is going to request for any EC2 instance to be hosted upon this physical interface, he's going to set out a request, and this hypervisor is going to ensure that it will have a set of hard disk as well as the memory. So this hypervisor is going to divide the amount of hard disk and the memory that is being required for this customer, and it is also going to keep out this security group which is to be tagged to this one. And we have a firewall, so security groups and the firewall together ensure that the isolation completely happens up. So I will not be able to access what is happening in the EC2 instance of a nearby customer, right? So if I have launched a Windows instance, the nearby person could have launched a Linux, or maybe he could have also launched a Windows itself. but still I'll not be able to access any of the things from what he's been doing, because these security groups and the firewall between the physical interface and the hypervisor are the one that actually completely create the isolation place. So the AWS firewall resides between the hypervisor layer and the physical network, right? And the instance virtual interface. So this is the virtual interface of the EC2 instance, and this is the hypervisor firewall, right? So between the physical interface we and the hypervisor, we have a firewall which actually prevents all the requests from having access to each other. So all the packets must pass through this layer. Thus an instance neighbors have no more access to that instance on than any other host on the internet, and can be treated as if they are on a separate physical host. The physical RAM is also separated using the similar mechanism. So you might think that since we are also sharing the hard disk, will I be able to view the hard disk of my nearby person? No. Customers instances have no access to the raw hard disk, but instead are presented with a virtualized disk, right? So whatever disk we are basically getting, it is all a virtualized disk that is automatically reset once the block of storage is used by the customer. So let's say I have been using an EC2 instance with a 10 GB of data storage for last 1 year. Now inside the 10 GB of hard disk, there's a lot of data which I have stored. So what happens when I am going to terminate the EC2 instance? What happens to the data, right? So in this case, whenever I'm going to release back my machine or say I want to terminate this, the virtualization layer will automatically reset block of storage used by the customer, right? So it's completely going to reset the block of storage. So if you remember disk zeroing or disk zeroing, so what happens in the disk zeroing is they completely format the hard disk and the sectors of the hard disk. So sometimes what people can do is, let's say if I have a hard disk and I have a laptop or a computer, or now let's say I have used it for 5 years and I wanted to give it to someone else for the usage. So before I give it to him, I might completely remove the data and format the hard disk and give it to the other person to use. So will the other person be able to recover what kind of data was there on my hard disk? Yes, he will be able to recover it back to see through what type of data is there, because I have deleted it from my hard disk, but it still exists on the sectors, right? So usually what happens inside of the hard disk is we have sectors like this inside which 0101 would be placed across, right? Now if you already know what kind of combination existed before, right? So whenever I say the delete or deletion of data to happen on the AWS cloud or any hard disk, not the AWS cloud but on any hard disk, whenever I say delete the data, let's say I have stored some PDF file and it got stored like this. Okay, so whenever I'm going to delete it, this still exists. It's just that from the virtual interface I'll not be able to see that the data is there anymore on the disk. But if I'm trying to use any of the methods of recovering the hard disk, again I go back to this sector and say that what was existing before, I'll be able to easily find out. So what Amazon does is, even these techniques could not be applied on any of the EC2 instances, right? So let's say we have been using the EC2 instance for last 1 year, and now we go ahead and say that I want to terminate the EC2 instance back, but it had a hard disk of 100 GB, which has got immense data, or maybe it is very confidential data. Of course, we have deleted everything from the hard disk, but there may be a case that whenever someone else is spinning up the machine, he may get the same hard disk, virtual hard disk presented to him. So will he be able to use the techniques of recovering the data and get it back? No, he'll not be able to do it, because what happens is Amazon is basically trying to do disk zeroing, right? So they are trying to set out every sector with a zero, so that it clearly says that nothing existed before on this hard disk, and he will not be able to recover it back. So usually we are going to say it as a disk zeroing, and we make all the sectors inside the hard disk to be set to zero, so that no customer data is being unintentionally exposed to another. So in addition, what happens? So this is the process. What happens? So memory allocated to guest is scrubbed, right? So we are completely going to rub the memory. How? By setting it to 0, which is called as disk zeroing. By hypervisor, when it is unallocated to the guest, the memory is not returned to the pool of free memory available for the new allocations until the memory scrubbing is complete. So whenever I am going to terminate the EC2 instance, the memory whatever I have been using, right? So it will not be given to any other customer until the scrubbing is completed at all, right? So we can be sure that Amazon has clearly taken care of these points where the data exposure could have happened. But yes, there was some time back when there was a case for one of the companies whose data got exposed like this. And now all the cloud companies usually follow this standard process where the scrubbing of the data is done to size set to 0 so that none of the data gets exposed. Now talking about the guest operating system here, the virtual instances are completely controlled by you, the customer. You have the full root access or the administrative access over the accounts, services or the applications, right? In terms of security, always understand that it is only the data center part which Amazon is going to take care. Whatever systems you are going to create, like virtual system we are going to create, it is completely under your control. So you have the full root access and the administrative control over who can access this EC2 instance. So let's say if I go to my AWS account, I spin up one of my EC2 instance, then I only have the full access to that EC2 instance. Even Amazon does not have any right to get inside my EC2 instance because the key pair gets dynamically generated and that key pair only exists with me in my machine. So Amazon does not have any right to directly access your instance at all, right? So if people might be thinking that Amazon would have got access to all the data that is already there in the data centers, no, they do not have any access to that. They have only set up the physical infrastructure, but whatever we are trying to spin it on the top of it, it is completely accessible by us. Specifically in the terms of the EC2 instances, they do not have any access because we have spinned up a system and it is accessible with the key pair and I have the complete administrative access. So until unless I do not add any specific user from outside world, they will not have any access at all. And in terms of firewall, Amazon EC2 provides a complete firewall solution. This is mandatory inbound connection is configured with a default deny all mode, and the EC2 customers explicitly open up the ports. So even in sometimes we may complain that I had attached a firewall that is with the terms of security group to the EC2 instance, and someone had actually accidentally logged in into the server and has been able to steal all the information. No, it cannot happen because whatever default security groups or the default NACL groups are there, you might have seen that the inbound connection is configured in such a way that it is in the deny all mode. So even by mistake, if you have created some EC2 instance which doesn't have any security group attached, it will be automatically getting attached to the default security group and the default NACL, right? So in the default NACL and the default security group, remember the inbound rules are completely in the deny mode. So from outside world, no one will be able to log in into it until unless explicitly you have opened up the inbound port. So Amazon has taken up care in all those parts of security wherever it has been necessary. And the encryption of the sensitive data is generally a good practice, and the AWS provides the ability to encrypt the volumes and the snapshots with the AES-256 encryption methods. AES-256 is industry's the best standard form of encrypting the data. So we know that there are two different types of encryption. One is server side and the one is client side. And in the server side, we know that there are again two different types. It is SSC-S3, SSC-KMS, and the SSCC, as well as the custom encryption at the customer side. So we can make use of any of these four encryption methods and set it across with the industry standard of AES-256 methodology. And the encryption basically occurs on the servers that host the EC2 instances, providing the encryption of data as it moves between the EC2 instances and the EBS storage. So we can completely encrypt the data which is stored on the EBS with the help of these methods, and it will be as per the industry standards AES-256 methodology. And in order to do this efficiently and with a low latency, the EBS encryption feature is available only on the EC2's most powerful instances. So if you have checked out, whenever we see the root volume for the T2 micro might not be encrypted at all. That is because it's a very small machine in this case here, and encryption feature is available only for the machines which are with a very higher size, specifically that starts with the M3, C3, R3 and the G2. And SSL termination. So specifically what happens is we see that most of our websites are operating at the port 443, that is HTTPS connection, right? So how can we deal with the SSL termination? So somewhere we have to terminate our SSL connection, and then we have to move towards the next part. So we are going to terminate the SSL at the load balancing itself. Remember, we open up the ports like 443 and port 80 on the security groups. So the port 443 is all about the SSL, where we can actually secure the complete environment. So we usually what we do is we will have a security group which will have the port 443 opened up, and that kind of security group will be usually attached to the load balancer. However, the security group with the port number 80 will be attached to the EC2 instance. Now between the load balancer and the EC2 instance, we are going to have a normal connection at the port 80, but however the public who is trying to access the load balancer from outside world, they are going to access it over the SSL certificates. So the SSL is going to get terminated on the load balancer, and after that a normal connection would go back to my servers in the backend. So it basically allows you to identify the originating IP address of a client connecting to your servers, whether you are using the HTTPS or the TCP load balancing. So that was about the first part of our white papers in terms of the security. Looking out at the second part. In the second part, we discuss more about how we architect the cloud in the better methodology. Now we understand how the security is being set up, how we can convince the customer that yes, we can actually move our assets towards the cloud. Cloud is really safe, there's no problem with it. Now, how do we help him to architect the best solutions in the world, right? So here are some of the best techniques. So first, we help them to understand what are the benefits of the cloud. So we all know that there is no upfront infrastructure investment at all when we talk in terms of the cloud, right? So in the normal cases, we have to keep a physical data center, which requires a space, which requires us to buy a lot of things like racks, networks, pipelines, switches, and a lot of other things, right? So apart from that, if you go down to the cloud, we do not have to purchase anything in terms of infrastructure. All I need is just the internet to get connected towards my cloud, and from there I'll be able to start spinning my resources. Just in time infrastructure. So the moment you think I want an infrastructure to be hosted up, it can be immediately done on the cloud. More efficient resource utilization. So in this case, whenever I shut down my servers at the night time, let's say my servers are needed to be switched on only from the 9 a.m. in the morning to the 9 p.m. in the evening, right? So we can specifically go ahead and close the servers as well, right? Shut down the servers. So like the way we do it at the home, right? So when we are switching off our tube lights at the night time, we usually do not have any power consumption. Similarly, what we can do is in the cloud as well, we can shut down our servers, which are going to basically save our cost. And then we are going to pay the cost to our cloud data centers only for the amount of time we are basically using it, right? So that's why we call it as usage based costing. And then we have reduced time to market. So whenever you want to go towards the cloud, it is we do not have to spend much time towards it, right? So immediately log in over the internet, get connected to a cloud data centers, and then start spinning up the data and put across it and create a web servers as well. And usually, what are the benefits of going to the cloud? Technical benefits. So we have something called as automation. where we just write everything in terms of script, and with a one click we are going to completely host our infrastructure, right? So we can actually completely automate it, and then we can actually see that auto scaling can also happen. So whenever the load is increasing, automatically the systems are increasing in the numbers so that the load is automatically balanced. So we have different types of auto scaling like proactive scaling and other things, and the more efficient development life cycle. So when we are on the cloud, the development life cycle will be much more efficient. I'll have an improved testability, disaster recovery, and the business continuity. So we can actually create the things for DR and the BC. DR basically stands for the disaster recovery. So what happens, let's say if I have hosted everything on the Mumbai servers, so there might be a question from a company's authoritative person or maybe from some other people, like what happens if I try to store the data in the AWS cloud data center in the Mumbai region, if completely Mumbai region itself is down, let's say due to tsunami or something has come up, some physical disaster has really occurred off. So what happens to my data, right? So usually whenever we are trying to architect a solution as a architect, we need to ensure that whatever data we are trying to put on the AWS data centers in Mumbai, I'll try to back it up in some other region as well. So maybe I'll use either the Sydney region or maybe the Ireland region or maybe the London region or maybe some other region in the AWS itself, where I'm going to take a complete backup. So that is going to be basically disaster recovery, and the business continuity is basically to ensure that even if the Mumbai region is down, I still have my data in the some other region, and from there I'll ensure that the people are able to access it. And then the overflow the traffic to the cloud. So even though the traffic on the cloud increases, it doesn't matter. Now we all see that the websites like Hotstar, right? So what happens in that specifically, they are trying to host a live cricket match, so whenever it's going to happen through. So there might be a chance that today whenever there's a match, my website might get popular, and there might be 10,000s or more than 10,000s of requests which are coming to it, right? So will cloud be able to handle that kind of situations? Yes, it will be able to handle it. There's no specific problem with it. So this is the elasticity diagram of AWS cloud. So if you see something on the left, on the x-axis, it is basically showing the time. On the y-axis, we are trying to keep the costing of our infrastructure. Now what happens in the normal methodology and what happens when we are trying to move to the cloud, right? So let's understand here. So usually we expect that over the time my company is going to grow like this, right? Whatever is shown depicted in the dotted line, we are expecting that over the time I am going to grow like this itself. So today it might be the 1st of January, but maybe by the end of this year I might have a bigger infrastructure inside the cloud, in which I would have invested so many number of dollars, right? So expectation is like this, but what happens in the real time? So let's say if I'm not using the cloud, then what happens for the physical data centers? Initially I have to put up the cost. So if you see, the blue line is already at a high cost, so I need a lot of money in my hand to get started. In case if there's nothing like a cloud, I have to go ahead and purchase the servers and then put it in my company and then get started, right? So initially I need to put across lot of money here, then my people will start working on it, and over the time people are working, and then we have created an infrastructure. But now we realize that there is a lot of audience that is actually accessing my servers. Again, we need to increase the size of my physical data center. So again we put in a lot of money here, and then again we are starting to work ahead, right? So we have been creating the resources like servers, databases, and then we are still working on. Again, at some point of time we would realize that we need to again add the money to pump up our infrastructure, right? So in normal general case scenarios where I have to set up a physical data center, I always need to keep pumping in money at certain point of time, and that money is really huge at that point, right? So exactly at the start I need at least minimum 10 lakhs or something to start off with. Again at the middle I would require one again set of 5 lakhs, and maybe again I would require 5 lakhs or something as such to create the data centers. Now again after 5 years as well, as we all know, this hard disks, the servers, they get deprecated, or over the time they are outdated. So I would actually make them get a newer one, right? So again, that is a cost to my infrastructure. So what happens in the AWS cloud? Sorry. So in the AWS cloud, we can start with as minimum as 0, right? So if you see this, the green line and the red line, they're actually predicting how we can actually grow in the AWS cloud. So I start with a 0. I do not have any infrastructure cost. I can straight away get started by spinning up the servers and then see through what's happening. And maybe initially I would have given a higher capacity of machine. So that's why we are putting up a little higher cost. But we realize that, okay, only 100 clients are accessing this machine, so maybe we can reduce the size. So again, we have a opportunity to reduce the cost, but in our first case, we can never reduce our cost at all, right? So in terms of the cloud, we will always get an opportunity to reduce the cost wherever it is possible. And again, if it is increased, if we want to ensure that we want to grow it, we will be able to easily grow it, right? So whenever we launched website like Flipkart or Amazon came into market, of course they were not so much popular today what they are today. No, they were not popular as the same 10 years back, right? So when Flipkart was launched in 2007, that is 11 years back, it was just started with few people, but today he is getting orders every 1 hour, right? So you can imagine the number of orders that are being placed across. So today he might be at this point because he has invested heavily in the infrastructure, and he has got lots of servers which are always running 24/7 and ensuring that the people always trust the Flipkart, that it is available 24/7 and the orders get processed at any point in time, right? So those kind of situations might also come through when we are at a higher point. So this is about the understanding how the elasticity works on the cloud in terms of the cost and the time. So any questions here on the today's part of our session before we close it out? How about you, Rahul? Any questions here?
No problem.
Oh. So in the next part of our session, we are going to wrap up our white papers, and then we are going to look out at few of the sessions that we were yet to cover up. So we are going to next look at what is ALB, what is NLB, that is application load balancer, and the network load balancer. So we are going to look forward with that specific section in this case, right? So we have just few more slides to cover up the white papers on how we can design and decouple our components, and then we are going to understand what are the different types of applications that usually exist in the real-time world, that is 2-tier and 3-tier applications, and how are they actually built as a part of architecting the cloud services. So we're going to learn that, and then we are going to look into our topics of NLB and the ALB, that is network load balancer and the application load balancer. Thanks all. So we'll meet back again tomorrow at early morning at 7 to continue back the next part of our session. Have a great day.